All right, so let's go ahead and look at number 9. So I want you to identify which one is arctangent, which one is long division, which one is natural log. Arctangent is which one? Which one's the arctangent? Middle, right? Which one is natural log? C. What about the first one is what then? Long division. What's your clue, by the way, it's long division? Powers are the same, or they could be higher on the top. They could be higher on the top. All right, first of all, I want you to go do the long division on A. Why don't you go do the long division on part A? Yeah, 9A, I want you to do the long division.
What's on the inside?
I think it's the smaller one that's on the inside.
Oh, yeah, duh.
X squared plus 81.
No. 2x squared.
So when you divide it by
What you're dividing by is what's on the outside.
Okay. Okay, so you can do a 2. Multiply that by 2, so that would become
Oh, right. Can I like just separate the separate the 2x
What's 81
squared
times 2?
and or is that
No.
not-
Oh, it's just not my Wait, am I doing it wrong?
You can, but you still have to do long division.
Oh, wait. I was like, what is it? And then you subtract that.
Wait, what is it?
So this equals 152. Negative 152. You can't do anything with that.
162? Is that what this is?
X squared plus 81.
So the answer is 2, and then there's like a remainder, which is...
Okay, remember, we just worry about the powers, correct? Okay, how many times does x squared go into 2x squared? It goes in there what? Twice, right? Then I multiply 2 times that, and I get 2x squared plus 162. But what am I doing with those now? I'm subtracting, so I get a remainder of 152. So I'm going to go rewrite what my antiderivative is. What's my antiderivative? What we still, we haven't found antiderivative. What does that simplify to be is what? 2, then what? Minus 152 over what? X squared plus 81. And sadly, somebody will leave that as their antiderivative, which we just did long division, that's it. So now, what's the antiderivative of 2 is just what? 2x. And what is the 152 over x squared plus 81 is our what? Arctangent. So it's minus 152 over what? 9 arctan of what? X over 9 plus c. Does 3 or 9 divide 152? No. If you sum the digits, we get what? 8, right? 1 plus 5 plus 2 is 8. That's not divisible by 3, so it doesn't work. So that's as simplified as it what? Gets. So let's look at the next one. So we know that's an arctan, so it's going to be what then?
2 over 9 arctan.
2 over 9 arctan of x over 9 plus c. All right. All right, C. So you notice we've hammered these a few times, haven't we?
Oh, yeah.
So what are we gonna? If we do a substitution here, we're gonna let u equal x squared plus 81. What's du then? Du is 2x dx. Do I have that?
Yes.
Exactly that. So this becomes du over u, which hopefully we recognize is a what? Natural log. So it's a natural log. I'm going to go straight to my answer. It's natural log of the absolute value of u, or I guess you could write as natural log of the absolute value of u plus c, or you go straight to absolute value of what then? Plus 81 plus C. Now, in this case, do I need the absolute value? No.
But
If it were minus 81, I would, right?
gotta be safe.
Safe, be safe. All right. What about number 11? What method are we using? What do we call the A and B thing? And what? First of all, why do you think what do we call that? Partial fractions. Okay? What's our clue that we're going to use partial fractions?
Oh,
Bottom is factorable, right? What does the bottom factor to? Yes.
X minus 7, X plus 5.
X minus 7x plus 5. So we're going to go, folks, please. Doesn't matter what you put where, but once you establish where with that, remember, you got to stick A and B there. Because once you establish the location of your A and B, when you solve for those constants, they go back to where you assigned it, correct? All right. So what do we do at this point?
X plus 3 equals
Oh, wait, we got to multiply through by the denominator, which gives us what?
X plus 3,
Equals what then?
X.
A times x plus 5 plus b times what? X minus 7. Because remember, when I multiply through by that on the top, the x minus 7 cancels, so you're left only with an x plus 5. Same way with the b, the x plus 5 cancels, so you're left with that. Now, we could pick any value, but we'd like to avoid a system of what? Equations. So what are our convenient numbers? -5 and what?
7.
And 7. Okay, the other thing is, too, if you remember from last time, are we going to get, are A and B going to be the same but opposite?
No.
No.
It's gotta be 3 more.
The minute it's x, that there's an x there, it won't. If it were just 3, would they be the same but opposite? Yes. Okay. So let's go ahead and figure this out. When x is -5, the left side becomes -2. The right side becomes what? -12b. So b is equal to 1 what? 6th, yes? Okay. When x is 7, the left side is 10. And then I get 12a over here, correct? Bless you. So what does a equal? 5, 6. So they're definitely not equal, and they're both positive this time. All right. So let's go rewrite our antiderivative based on how we assigned it. So it's going to be 5/6 over x minus 7 plus 1/6 over what? X plus 5 dx. And the nice thing is when we use partial fractions, they're always natural logs. Now, I want to point something out here. We will not do ones that it factors to x plus 9 and an x plus 9, where it's a double factor. We just don't do it in here. It's a little more complicated. It's not A and B. It's actually an A and like a bx plus c type of thing because it's actually a squared term. There are far more complex, but this is the limit that we go to, just so you know that. When my son took it at North Central, there were some crazy ones that we had to do. And I was like, oh, okay, I got to learn this. So, all right. So let's come up with our answer. So what's this going to be? 5/6 ln of what? And then this is 1/6 ln of x plus 5 plus c. And there's nothing that we'll really do with that, but I do want to point this out because there was a different author, not an AP author, but a review book author that did combine those together. And I want to show you how you could do it. Do they both have the same denominator on those fractions?
They do.
So what can I do with that 5?
Add it to the 1.
I can move it to be an exponent here, right?
Oh, yeah.
Also, you
Using our log rules, so I'm going to rewrite it as 1/6 ln of the absolute value of x minus 7, and that's now to the 5th, plus 1/6 ln of the absolute value of x plus 5 plus c. Now, could I combine them?
Yes.
Yes. Okay, so it would be 1/6 ln. Am I multiplying or am I dividing? I'm not dividing.
What's
They're both positive, correct?
Yeah.
So positive, when there's addition with logs, it means we're multiplying. So in one big absolute value, we're going to put what? X minus 7 to the 5th times what? X plus 5 plus C. Okay. This is your best one as far as I'm concerned. I just wanted to remind, because of your rules of logs, it is possible if that coefficient out front, by the way, you could, and I want to point this out, it doesn't matter what it is out front. Could you always put that entire fraction as the exponent and combine them? Yeah, you could. So, all right, last one of the day, I think. Maybe, we'll see.
It's gonna probably have to be.
Okay,
Unfortunately.
so my question to you, parts yes or parts no, or parts unknown?
Parts unknown.
Yes.
Why do we have to? The answer is yes, why? Well, if you take this as u, is that its derivative in front?
No.
No, therefore you have to use parts. Can you use the tabular method? Yes. Okay. I don't care which way you do it. I want you to set it up and do it. I will probably do the tabular method.
I like that.
And just remember, what are the two cases you can't use it for is when it's what?
ln.
Natural log or the arctangent.
Arc sign doesn't work either.
Correct. Any of the arcs.
Then there's also an e.
I will tell you, the fractions get pretty ugly on this.
Yeah.
If you do it normal function, you bring out a 1/8, right? Because it's G.
If you're differentiating, you bring on an 8, right?
An 8 or a 1/8?
No, if you were differentiating, you'd bring out an 8. So when you're doing an antiderivative, what's coming out front? A 1/8, right?
I didn't do that. 32 times Jesus.
So next class, Mr. Jones, we're gonna finish this packet and do a quiz.
Yes.
How hard is the quiz?
Okay. How would you ask that?
I don't know.
Why would what answer would he give you? That is a stupid question.
All right, let's go. All right. If you differentiate u, it's 10x. If I differentiate till I get to 0, this is going to be 10. This is going to be what? 0. What goes in front then? A plus, a minus, and a plus, right? We don't really use the 0. That's okay. All right. Now we need to integrate the next one twice. So if we do the antiderivative the first time, it's going to be 8x plus 2. What's my power? 4/3. And I got two things out front. They are what? 3/4, and I'm going to get a 1/8. So that essentially becomes what? 3/32? Yep. Okay. That's just a reminder because that's what I'm going to pull down for the next one. All right. So this is going to make it, so I'm going to leave that 3/32 there. What does my new power become? 7/3, and what's in front now? A 3/7 and another what? 1/8. Okay. Are there any things I can, no, there's nothing I can simplify, is there? No. And then that's your 8x plus 2. But the nice thing is, we don't have a lot left to do we? So now remember, we're multiplying on the diagonals. Okay, so if we just do that first one, that's going to be 30x over 32, correct? What does that become? 15, yeah, I get 15x over 16 times our 8x plus 2 to the 4/3, right? What is the SIGN on the second one? Is negative, right? So that becomes 90. I'm going to do a 10 times 3 times 3. And then I have an 8 times 7 times 32. I think I have a 2 that would come out. Is that right? Doesn't matter where I take it out of. So instead of 90, it's going to be 45. Is that right?
Yeah.
Yeah. So it's 45. 56 times 16. Did anybody do that yet? 896. So it's 45 over 896. And by the way, I don't think I'd give you one this bad.
Would it be no calc?
Yeah, you're probably not going to have a calculator on this one. And then it's to the what power? Or it's 8x plus 2 to the what power? 7/3 plus what? C. So somebody asked about slope fields. I just want you to realize something. As far as on an assessment, there are one of two ways you could see it. What's one? Draw it, right? What's the other one? Matching. So it could be draw one, could be matched, could be both. Somebody did ask in the other class, a couple people asked for some review stuff. I'm going to put up, I know we need some help on Euler's method, so I will put up an Euler's method question with solution. And I'll also probably do some straight substitution and maybe a couple parts on there too. Okay. It may be handwritten just because of time to get it done. So it might be in the Jones font.